Hi guys, this is chapter 2 lecture on chemistry. First we're going to look at some basic structures of life, looking at matter. So mass that occupies space. An element can be a pure substance, which we'll look at some elements here in a minute. Compounds are taking those elements and combining them to produce a new substance. So looking at our atoms, we have protons, electrons, and neutrons. You need to remember that protons, P for positive, have a positive charge, whereas your electrons have a negative charge and your neutrals, N for neutral. Please memorize that. Looking at an atom here, so we have our nucleus found in the center. And we have an equal number of protons and neutrons. Then you have the protons will equal our electrons that are floating or orbiting around the nucleus. So we have 1, 2, 3, 4, 5, 6 electrons. We will talk about tomorrow about each and every energy shell and how many electrons are found in each shell. Let me move on to put up a video. Let's see. All about atoms.
Anything that has mass and occupies space is called matter. In turn, matter consists of either elements, which are pure substances that can't be broken down into two or more substances, or compounds, which are chemical combinations of two or more elements. Water, for example, is a compound formed by the combination of two atoms of hydrogen and one atom of oxygen. Hydrogen and oxygen are elements because they cannot be further broken down or decomposed chemically. Elements consist of particles called atoms. Atoms, in turn, consist of even smaller particles called protons, neutrons, and electrons. Protons, which have a positive charge, and neutrons, which are electrically neutral, are packed together in the center of the atom called the nucleus. The number of protons in the nucleus determines the element's atomic number. For example, hydrogen has 1 proton, so its atomic number is 1. Oxygen has 8 protons, so it has an atomic number of 8. Whirling around the nucleus are one or more concentric clouds of electrons, tiny particles with a negative charge. Each ring around the nucleus represents one cloud or shell. The number of shells varies between atoms. For example, hydrogen has only 1 shell, whereas oxygen has 2. The heaviest natural element, uranium, has an atomic number of 92 and 7 electron shells. Each shell can hold a certain maximum number of electrons. The shell closest to the nucleus can hold 2 electrons. Each of the outer shells can hold 8 electrons. Once again, atoms consist of light negative electrons, heavy positive protons, and heavy neutrons. In turn, atoms build up elements and compounds, which combine in various ways to form matter.
Okay. The atomic number and the atomic weight. So the atomic number of protons in the nucleus, if you're looking in your book, as well as the periodic table that I've given you, you will see the atomic number at the very top. So the atomic number, like oxygen, would be 8. The atomic weight are the protons and the neutrons, the weight of that element. And that's going to be at the very bottom, that really long number that you'll see. Not of importance to us just yet. So, which of the following is a pure substance that cannot be broken down into two or more substances? So a compound can definitely be broken down. Matter can even be broken down. So we're left with B, your element. So two or more, a compound consists of two or more elements. Matter is any substance that has mass. Atoms are particles that make up elements. So the key should have been pure substance cannot be broken down into two or more substances. An atom is one all on its own. We'll talk about some chemical bonds and we'll practice these. But right now, let's just talk about ionic bond. Just basically what it is. We will actually practice this and you'll know it in depth. So right now, an ionic bond is just stealing of an electron. So they don't actually touch. They just kind of float around attracted to each other because of their positive and negative charges. So because of their opposite charges, they are attracted to each other. So this one stole that one, put it over here. Whereas, same thing, they're attracted, they're opposite charges. Oops. Unlike covalent bonds. Covalent bonds I think of as couples. They hold hands. So here we have a covalent bond sharing another covalent bond, and they're sharing electrons. Again, we will practice these and we will do these later on. So, on to our next video.
An atom's outer electron shell can hold a maximum of 8 electrons. An atom with a full outer shell is said to be stable. However, most atoms are not stable because their outer shell is not full. These atoms attempt to lose, gain, or share electrons in their outer shells to become stable. They do this by forming chemical bonds. Two types of bonds are ionic and covalent bonds. Ionic bonds are formed when one atom transfers an electron from its outer shell to another atom. Because electrons are negatively charged, when an atom gains or loses an electron, its overall charge changes from neutral to either positive or negative. Electrically charged atoms are called ions. The positively charged sodium ion, Na+, is attracted to the negatively charged chloride ion, Cl-. The electrostatic force draws the two atoms together, forming an ionic bond, which results in sodium chloride, or ordinary table salt. In covalent bonds, instead of transferring an electron, two atoms share one or more pairs of electrons as they attempt to fill their outer shells. For example, if two atoms of hydrogen share their electrons, their inner shells would be full. Thus, a single covalent bond exists and hydrogen gas, H2, is formed. Double covalent bonds may also occur, in which atoms are bound together through the sharing of two electrons. For example, when one carbon atom shares one pair of electrons with each oxygen atom, a molecule of carbon dioxide is formed. Both ionic interaction and covalent interaction result in a molecule, a particle composed of two or more atoms united by a chemical bond. The microscopic world of atoms and molecules forms the foundation of life.
Okay, hydrogen bond. Again, it's going to be not only, this is a water molecule, so then you would have another water molecule And because of the opposite charges, they're attracted to each other. Very similar to the ionic bond, but this is called hydrogen bonding because it's only dealing with the hydrogens that are on there. So, even though this is a covalent bond of water, this guy is bigger and stronger, so he's pulling those electrons from that hydrogen over to here the majority of the time. So that means I have more protons positively charged over electrons. Same here. I'm big and strong, and I'm pulling these electrons and kind of keeping them on my side the majority of the time. So that means I have more negative than I have positive, so my overall charge is negative. And then I have another water molecule out here where the positive is attracted to that negative. We will go over this again and practice it in our activities in the class. So that's what's happening. Those two water molecules are coming close to each other because they're attracted to the opposite charges.
Besides ionic bonds and covalent bonds, certain atoms may interact through hydrogen bonds. Although hydrogen bonds don't form molecules, they are very important in explaining properties of some fluids. Let's look at how this interaction bonds water molecules. Water consists of two hydrogen atoms bonded with covalent bonds to an atom of oxygen. In the bonding process, oxygen shared two of the electrons in its outer shell with hydrogen. Even after bonding, it has 4 additional electrons in its outer shell. These unpaired electrons give water a partial negative charge near the oxygen atom. At the same time, the two hydrogen atoms create a slight positive charge on the other side of the molecule. Uneven distribution of electrons makes water a polar molecule. The partially positive oxygen side of one molecule is attracted to the partially negative hydrogen side of another molecule. This attraction results in a weak attachment, hydrogen bond, between water molecules. Although hydrogen bonds don't form a new molecule, the ability of water molecules to form hydrogen bonds with other water molecules gives water many unique properties necessary for human life. Besides ionic bonds and covalent bonds,
So, what bond occurs when one atom transfers an electron to another atom? So it steals one and takes it for its own. Hydrogen bonding, they don't actually steal. There's lots of covalent bonding and then some attraction. Chemical, ionic bonding, possibly. Covalent bonding, we think of couples sharing and holding hands. So it is C, ionic bonding. Let's stop there and we'll pick up right after this.